take a look at these tables. Who can tell me what pattern they noticed in table A? Emmett?
Every time it adds 7.5.
Yeah, so repeated addition tells me this is what type of function?
Linear.
Linear. So 7 plus 25 plus 7.5. I've got 32.5 here. Notice it jumps to 25. So I'm going to choose to build a function to use so I can input 25 and get an answer. So y equals, what's my initial value?
2.5.
And what's happening over and over?
Plus 7.5.
I'm multiplying by 7.5 over and over. The number of times, the number of times I add a difference of 7.5 there depends on what my input is. So I need to add 7.5 25 times. 2.5 plus 7.5 times 25. That gives me 190. Okay? So again, here's where I start when x is 0. Here's what's happening over and over. Repeated addition is multiplication. Let's go over here. What's the pattern happening here?
Exponential.
Well, it is exponential, but what's the pattern? Yeah, times 4. Times 4, times 4, times 4. So 160 times 4 is 640. To times 4 over and over 25 times, you're likely to like be one off, right? It's not, and it'd be a lot of buttons to hit. So let's do this. What's my initial value?
2.5.
And what's happening to that over and over?
You're hitting it 4 times.
Times 4, x times. So I'm going to put 25 in for x. 2.5 times 4 to the 25th. Oh, wow.
8.814.
Okay, I'm going to write down here. I got 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got this number.
That's a small number.
Yeah, it's my bank account, son. Okay,
Do you have that much money in your bank?
why is that number so big? Even though I only went to 25. Exponential functions. Remember that genie just doubling how big it got real quick? This is quadrupling over and over. Okay?
And that's real.
Yeah, Micah.
I was going to say that if you had that amount of money, you'd have enough to cripple the U.S. economy.
There we go. You know, we just talked, we got this pond full of algae. Okay? There's an algae bloom. This is where, like, all of a sudden, algae kind of happens rapidly when it happens. Well, you can combat an algae bloom with a chemical treatment. And this treatment's effectiveness on this pond can be measured with, right here, this function. A equals 240 times 1/3 to the t, where t is time. And A is area of algae. So you're going to go through and you're going to say with your partner what 240 and 1/3 mean in context. You are then going to graph this function for 1, 2, 3, 4 weeks. And then you're going to make a claim after 2.5 weeks how much algae is left. Is this going to be a growth or a decay function? Decay, right? This chemical is killing the algae. And fun fact, what type of living organism is algae? Plant's the number one wrong answer because of chloroplasts. It's not a bacteria. It's a
I
protist.
literally just said that. Yeah, I heard.
It's a protist. Fun fact. So as I walked around, I've seen enough to get us going, okay? In our function, the 240, who can tell me what that means in context? All right, Elliot. Yeah, I want to know what that 240 means in context.
240 means how much algae is in the lake.
Not how much. It's the starting area. Okay, so starting area of algae. And I know it's the starting area because if I would put a 0 in for time, I get 240, right? 240 times 1 is 240. What does the 1/3 tell us?
The 1/3 tells us that we lose 2/3 to get 1/3.
You lose 2/3. Yeah, each week, right? Does anything in the context say the fraction 2/3? No. But if we're left,
lose 2/3 to get.
yeah, if we're left with 1/3 in the function, that means we're losing 2/3 of the area a week, which seems like a big decrease, right? A whole lake's covered. After 1 week, 2/3 of it's gone. Okay?
They're all gone.
So let's graph this for some days. I'm going to go 1, 2, 3, 4 days. And then I'm going to go by 25s. 50, 100, 150, 200, 250. Okay, so at 0 days, what am I starting at? 240, so somewhere around here. And this is going to be area, and this is going to be weeks. After 1 week, how much is left then? If I had 240, I have a third left the next week. 1 week, I have 80. So right around here. Okay? I have a third left that next week, so 80 divided by 3, or 80 times 1/3. I have 26 and 2/3. So right about there. Another week, I have a third left. I have somewhere around 8.8. Somewhere, let's say right there. A third left of that after the next week, I have like 3. Is it ever going to get to 0? No. It will never get to 0. Because a third of something is always something. And
But it will get really close.
it's going to approach 0 forever, right? But
It'll be a fraction of
so do you notice when we had the growth, it approached infinity. When we had the decay, we're approaching 0. So the next question, I saw a lot of people as I walked around, and it's good. Oops. They went right here. They went to point 2.3 or 2.5 right here, and they said, it's about blah, blah, blah. Well, guess what, y'all? We have a function. I would not use the table. The area is equal to 240 to start. I'm going to multiply by 1/3, 2.5 times. Right? We didn't need to use the graph. We had the function. So 240 times 1/3 to the 2.5 is about 15.4. And what is it, the units? Feet? Square feet?
square yards.
Square yards. So after 2.5 weeks, that's how much is left. It seems like a big decrease. Again, once you stop treatment, what's going to happen though? As long as the weather's right and all that stuff. It's going to grow back. That's why algae is, I grew up on a 2-acre pond. Algae is a constant thing. Okay? Late summer, that thing's pretty slimy. But the fish like it. So then you got to decide, do you kill some? Well, when you kill some algae, it sucks a lot of oxygen out of the water, and the fish don't like that. So then you put it in an aerator. Well, then the plants like the aerator. Anyway, it's a mess. But it's a constant battle with the algae if you're trying to have a nice pond, all right? As you can tell, I know from experience. Next, we're going to talk about insulin. So, if you're a patient and you take insulin, you need insulin because maybe your pancreas stopped making it, and insulin moves blood, the sugar from your blood, into your cells and into fat. So, you need insulin. And fun fact, there wasn't really insulin until like sometime in the 50s, I think, and it came from horses. Now it's synthetic. But once the insulin gets in a body, it starts to breaking down, right? Your body has filters for its blood, several things that filter your blood. The big one being your liver. Liver, kidneys, yep. So this, you can see the values of the micrograms of insulin left in this patient's body each minute. All right, that's this graph. Does this look like exponential growth or decay? Decay, less and less. So your job is to figure out what fraction of the original insulin there was for 2 and 3. And then I want you to come up with a fraction of the insulin that remains. Okay, so just take your time, read through it a second time. You have values for 1, 2, and 3 minutes. You're going to find that ratio to start explaining the common factor of how this insulin is going through the body. So let's take a look. From as soon as it went in, next minute, it went down how many? So it went down 10, but it started at 100. So this means it went down a tenth, which leaves what?
9/10.
It leaves 9/10. Okay. So from 1 minute to 2 minutes, it went down.
10%.
It went down 9 out of 81, which is also 1/10, which leaves.
You mean 9 out of 90?
That's what I meant. That'd be 1/9. It went 9 out of 90. Okay. Yeah. That leaves how much? 9/10. So what's the fraction remaining? 9/10 each minute. All right. So let's build this function now. So 190, 79.2. So 72.9. If I want 9/10, I'm actually going to multiply by 0.9. You know I'm a big fraction guy, but times 0.9 in the calculator is a little nicer. We're going to get 6. Whoops. Not on the pen. No, wrong page. I'm just smashing buttons around here. Now it's not working.
Is it frozen?
I don't know. Uh-oh, technical difficulties. Okay, we got it back. 65.61. The next hour, how much is left? 9/10 is left of that, which is 59. 049. Okay. You all going to help me write an equation. How many micrograms are remaining after m minutes? So I'm going to say f of m. What's my initial value, everybody?
100.
What's happening to it?
9/10.
9/10 is left. How many times?
M times.
Depends on the minutes. This is the function for any number of minutes. This can also be 0.9.
Yeah, okay. That's
It's the same thing.
Yeah.
I'm kind of weird. You guys already know that. I will write 9/10 there, then put 0.9 in here. That's how I roll. Awesome. Is this decay or growth, you think? Decay. Show me your lesson summary to get the homework.